Quantum tricks again. Thanks for your interest. Before starting, if you're not yet subscribed to my channel Quantum Tricks, please do subscribe and don't forget to hit the bell button to get my latest updates. Now I'm going to present you the working model of motors with using motor driver L298N. We require Arduino Uno. If breadboard, it's optional. A L298N motor driver module. A screwdriver to loosen the screws. A plucker. Two DC motors with two wheels already connected. A battery 9 volts. Battery clip of 9 volt battery. Uno programming cable. Couple of male to female jumper wires and couple of male to male jumper wires. These are majorly used to connect Arduino to L298N motor driver module. First step, we are not going to use Arduino now. Let's check how does motor driver work practically. Take the L298N motor driver, then loosen the screws of motor 1 output. Then insert one of the wires inside and don't forget to tighten the screw. In the same way, connect even the second one and tighten the screw like this. In the same way, connect the second motor. Don't forget to loosen the screws. Make sure that your connections are thorough. Next step, take the battery and connect the battery clip. I have two crocodile clips. Using a wire, connect the positive terminal of the battery to 12 volt of the motor driver. Then take another wire, male to male, and then connect this wire to ground. Now you can observe that the light of the motor driver is glowing. Make sure that these connections are proper. As I told you when I was explaining the motor driver design, that it gives 5 volts output as well. Keep these two jumpers so that it will move in its top speed. Now let's see without Arduino how this works. Now you can see that motor 1 is rotating clockwise. And then now, if you keep it to the pin 2, the motor is rotating anti-clockwise. Now connect this to in3. Now motor 2 is rotating clockwise. If you keep it to in3, it will rotate anti-clockwise. Depending upon the trigger of the current in these 4 pins, the motor's motion changes. Now let's see how to connect with Arduino. Before starting connection with Arduino, don't forget to remove the battery connections so that your motor driver cannot fuse. Don't fuse. Remove the 5V out using a male-to-male jumper wire. The 5V out to the Arduino's 5V. You can see over here. The connections are as same as I shown you when I was showing only LED L298N tutorial. Now we are going to control the speed of the motors with Arduino's output signal. Let's remove the jumper which is placed over here. Using 6 male to female jumper wires, connect all the pins one by one to L298N Motor Driver and Arduino. Don't forget to keep the common ground. So connect the another male to male jumper wire to the ground pin. Keep the common ground, then connect the L298N's ground to Arduino's ground. Over here I am not using the breadboard, but you can use the breadboard to get the proper connections. Then connect the battery. Let's see how this works with the code. This is the code we need to upload to run the motor with the help of Arduino. Constant integer ENA equals to 5 is declared as pin number 5. This gives analog output. Constant int in1 equals to 6. In1 is for clockwise. In1 is for clockwise rotation of motor 1 and it is declared as pin number 6 of Arduino. In the same way, in2 is declared as pin number 7 and E and B pin. In3 is connected to pin number 8. In4 is connected to pin number 9 of Arduino. In void setup function, we need to write pin mode. Pin mode is a function. This function is explained in my previous tutorial. The previous tutorial link is given in the description. If you are a starter, it's better to refer the previous videos. ENA as output. In the same way, I wrote in1 output, in2 output, and ENB in3 and in4. Void demo_1. demo underscore 1 is a user-defined function. In place of demo underscore 1, you can write any name. But don't forget to keep these two brackets. Demo underscore 1 is declared in void loop function, and this will be explained when I am explaining void loop function. Analog write ENA equals to 200. There's no equal to sign, it's a comma sign, declares that motor stops rotating. Digital write info high, delay of 2000 milliseconds, which is 2 seconds. In demo 2, this is also a user defined function. Digital for loop, introduce a for loop to increase the speed of the motor. 0, I should be less than 100. It's a value, integer value, no units, I plus plus. If I is equal to 0 and I should be less than 100, that means it could be 99. From 0, it will increment. This statement increments the value of I. Analog write ENA, ENB high. You can see I introduced a variable I, and instead of high or low, I kept it as I, the variable, and I introduced a delay of 100, increase the speed of the motors from 0 to 100 and the delay is for 100 milliseconds, and I is equal to 100. Then analog write ENA I and ENB also I. The while loop function demo underscore 1 and delay is for 2000. Delay is here 2000. So this is the setup we require. Now let's upload the code. Now you can see that demo 1 is about to complete. Demo 1 is completed. There is a delay of 2 seconds. Now you can see that the two motors are slowly increasing their speed. As we wrote a for loop, it will increment I value, and now it's decremented and slowly it stopped. I introduced a delay of 2 seconds and now it's. If you like this video, please share, subscribe and like, and don't forget to hit the bell button to get my latest updates. Quantum Tricks!